All right, let's look at a polar question. This was from a free response. Also note as we're going through this problem, it was on the no calculator section, so we're not going to use our calculators. We're doing it. So for part A, they said let R be the shaded region you can see down here between the graph of R equals 4, which would be the circle here. We've looked at some of those graphs before in polar where you just graph a number, you're going to get a circle. And outside the other shape here, which looks like one of those cardioids we've seen before, that's the graph of this one. Write an expression for the integral of that shaded region, and they do tell us these intersection points up here, which are helpful. So pi over 3, if we were to graph 0 on this one, we're putting 0 in for the angle. Cosine 0 is 1, so that would be 2 times 1 or 2, and then 2 plus 3 would be 5. So you can see there's where 0 is here. And same with here would be 0. So that first intersection point, because we move counterclockwise, that's going to be the pi over 3 intersection point. There's our 5 pi over 3 intersection point. So we want to graph it from one to the other. So our area equation here for part A would be the integral from pi over 3 to 5 pi over 3 of 1/2 our radius, or our r squared. Now here you do have a little bit of a decision to make. Which one's the outer one, which one's the inner one? You can see from the picture down here, the circle ends up being the outer one. So we want to do that one first. That squared d theta minus the inner one, same limits here, pi over 3, 5 pi over 3. And this one would be 1/2 our r squared. So for this one, our r is that 3 plus 2 cosine theta. Make sure you get that squared on there again, d theta. That would give you full points. Another way you could write this answer that would also work here, you won't have to do both of these, would be combining them into one. So if you took that half and took the constant half out of both of these and factored it out, you could also write it as 1/2 the integral of pi over 3 to 5 pi over 3 of 4 squared minus this other function squared d theta, and write it as one integral. So either one of those would work. You don't have to do both, but either one of these would be a good answer and get you full points on the test. All right, let's take a look at part B. Same information, same graph. Find the slope of the tangent line to the graph of the cardioid part, r equals 3 plus 2 cosine theta at pi over 2. So if they're looking at pi over 2 here, what is that tangent line? What's the slope of that line right there? So what we got to do here is, we've looked at how to do these derivatives before. Our dy dx in this case is going to be our dy d theta over our dx d theta. So we want to find out what those two equations are. Remember to find your x and y here. That x equals r cosine theta and y equals r sine theta. So now we want to plug our r value in for those and find them. So we're putting r here and here. So that tells us x is going to be 3 plus 2 cosine theta, and y is 3 plus 2 cosine theta, sine theta. All right, so we're going to have to find the derivative of those. So to find our dy dx here, we need the derivatives of both of those. So let's start with the top here. If we're going to find the derivative of this over here, looks like we're going to have to do product rule to find that dy d theta there. So using product rule, that's going to be the first one. So 3 plus 2 cosine theta times derivative of the other part, which is sine theta. Derivative of sine theta is cosine theta, plus, now we switch them around, so we'll have sine theta times the derivative of 3 plus 2 cosine theta. Well, derivative of 3 is 0. Derivative of 2 cosine theta would be, derivative of cosine is negative sine, so negative 2 sine theta. All right, so that's the derivative of dy d theta. Now let's find dx d theta. So now we're finding derivative of this one. Again, I'm going to have to use product rule, so it'd be 3 plus 2 cosine theta. Derivative of cosine is negative sine. Plus, now we're switching around, so cosine theta times derivative of 3 plus 2 cosine theta, which we already did before, is going to end up being this. So that's our derivative. We want to now find what is this derivative at pi over 2. So we want to probably figure out first what is cosine pi over 2 and what is sine pi over 2, so we can fill in those values over here. Again, no calculator on this one, so you got to be able to figure that out. Remember, pi over 2 is like 90 degrees, so on our unit circle, that's right here. What's that ordered pair? 0, 1. And that, remember, our cosine is the first value. So that's telling us cosine pi over 2 is 0. That also means sine pi over 2 is 1. So wherever we have a cosine, put 0. Wherever we have a sine, put 1. So going back through this now, this is going to be 3 plus cosine of pi over 2, 0. So that's all going to be 0. Cosine pi over 2 is again going to be 0 here. Sine is 1. Again, sine here is 1. On the bottom, we get 3 plus cosine is going to end up being 0. Sine is 1, but this is negative, so it'd be negative 1 plus this is 0. And again, this is 1. So we want to now simplify that to get our slope. All this, if it's times 0, is just 0. So now I get 0. The other one, negative 2 times 1 is going to be negative 2. On the bottom, 3 times negative 1 is negative 3, plus 0 times anything 0. So it looks like our slope comes out to be negative 2 over negative 3, which if we're dividing two negatives would be positive 2/3. And that would be the answer we were looking for on that one. So that's the slope of this tangent line right here. All right, there was one more part to this free response. Part C, a particle moves along the portion of the curve r equals 3 plus 2 cosine theta from 0 to pi over 2. The particle moves in such a way that the distance between the particle and origin increases at a rate of 3 units per second. Find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to pi over 3. Indicate the units of measure. Well, if they're talking about this moving here, we want to take the derivative of our r equation, which is right here. So we want to take this equation and we want to differentiate it with respect to time. So what we're trying to find is what is dr dt here. So we want to, again, differentiate this with respect to time. So on the right side, if we take the derivative with respect to time, it'd just be 1 dr dt. On the other side, derivative of 3 is 0, it's a constant. Derivative of 2 cosine theta, well, derivative of cosine theta is negative sine theta, so this is going to become negative 2 sine theta derivative there, but it's a derivative of theta, so we need to include d theta dt with respect to time. All right, so now where they're asking us to find this at is at pi over 3. So what is the change when the angle here ends up being pi over 3? So we know that the angle's pi over 3, so we want to put that in there. They also tell us in here that the distance between the particle and the origin increases at a rate of 3 units per second. Okay, so that's talking about our, that's our dr dt here. So if you want to go through and do this kind of how we did where we have our know and show here, our know, or what we know here is that dr dt is 3. And we also know that theta here, or we're trying to find this when theta is pi over 3. So we should be able to substitute those pieces of information in. And what we're trying to find is at what rate is the angle changing with respect to time. So if we go back to our know and show here, what we're trying to show is what is d theta dt. Well, how's our angle changing? So let's substitute in and see what we got. Dr dt is 3. Our angle here is pi over 3, and we're trying to solve for d theta dt. That sine pi over 3 you are going to have to be able to evaluate without a calculator. If you want to do that and you're not sure, you could change this pi over 3 to degrees. If you don't remember what that is in degrees, 180 divided by 3 is 60 degrees. So if you got a 60-degree triangle in the unit circle where this is 1, what's the other side? Well, this side's half of that because it's half of a equilateral triangle here, and this side's square root of 3 over 2. So sine is your opposite side over your hypotenuse. That'd be square root of 3 over 2 over 1, or just square root of 3 over 2. So we get, sine of pi over 3 is square root of 3 over 2. We want to keep solving this now. These 2's should cancel here. So now we get this. And if we divide, looks like d theta dt here would be equal to 3 divided by negative square root of 3. That would work for an answer if you had it. You could also rationalize this if you multiply by square root of 3 over square root of 3. Square root of 3 times square root of 3 would just be 3, so these 3's cancel. So a little bit nicer way of writing it would then just be negative square root of 3. And they did say indicate units of measure on here, so make sure that you do that part of it as well, because that's part of the points here. Indicate the units of measure. Anytime you're measuring an angle, remember we're measuring an angle here, that would be in radians, because degrees were never mentioned. And then you got to figure out time. If we go back to the top, it said on this one that time was measured here in, looks like in seconds. So this would be radians per second when writing our units of measure here. So radians per second. And that would be our final answer, and that was the correct answer on this one. So that gives you an example of one of these polar questions. That was a FRQ on the AP exam.